Hi, welcome back to my channel. My name is Gina. In this video, we are going to talk about when square root is involved in the limit of type 0 over 0. Let's do a quick recap. Usually when we compute limit, we simply need to substitute the a, the number, into the function. If we are trying to find limit as x approaches a of a function. However, if the function is the form of f of x over g of x, then when you substitute a, there are three possibilities. The first one is you'll get a number over a non-zero number. Then in that case, the limit of this function is simply L over n. The second possibility is you can get a non-zero number over 0. But you can never have 0 in the denominator. So in this case, it means the limit does not exist. The limit will either goes to positive or negative infinity. And it happens when there's a vertical asymptote at x equals to a. And the third possibility is when you get 0 over 0. If you get 0 over 0, it means the cheating rule doesn't help, and the cheating rule is inconclusive. And just a quick note, 0 over 0 is the same thing as 0 times infinity, because you can write it as 0 times infinity over 1, and if you move the infinity over 1 into the denominator, you get 0 over 1 over infinity. And 1 over a really large number is 0. So this is the same thing as 0 over 0. This is also equivalent to infinity over infinity. Using the same argument, we can put the infinity in the numerator to the denominator and write it as 1 over infinity. And move the infinity in the denominator to the numerator and write it as 1 over infinity. And that is the same thing as 0 over 0. And the techniques to solve this kind of limit is to complete the difference of square, simplify or factorization, or put the function in common denominator. An example to complete the difference of squares, when you have a function of x over a function of x minus another function of x. Let's call them a, b, and c. Then to complete the difference of squares in the denominator, we can multiply the function by the denominator, but we are going to change the sign from minus to plus. So we are going to times b of x plus c of x divided by the same term, b of x plus c of x. Then the denominator becomes b of x squared minus c of x squared. In the numerator, you simply multiply the f of x by b of x plus c of x. In this video, we are going to focus on when you have a limit that has square root and you get the third type, which is 0 over 0. Let's look at why you need to pay attention when there's square root in the limit. Just a quick recap. Absolute of x equals to positive x if x is positive, but it equals to negative of x if x is negative. For example, absolute of 2, since 2 is positive, so absolute of 2 is 2. But absolute of negative 2, since the x here is negative 2 and it's negative, so we need to add a negative sign in front of the x. And this also equals to 2. And a second note, square root of x squared. Since the result of a square root is always positive, so this equals to absolute of x. which again equals to x if x is positive and equals to negative x if x is negative. So for example, limit as x approaches infinity of square root of x squared, which equals to limit as x approaches infinity of absolute of x. And since x is approaching to positive infinity, so this equals to limit as x approaches infinity of x, which equals to infinity. However, limit as x approaches negative infinity of square root of x squared. The square root of x squared equals to absolute of x, but since in this case, the x is approaching to negative infinity, so we need to add a negative sign in front. So this equals to limit as x approaches negative infinity of negative x. We substitute the negative infinity into x, we'll still get positive infinity. Let's look at some examples. Limit as x approaches 0 of square root of x squared over x. We already talked about the square root of x squared. So this equals to limit as x approaches 0 of absolute of x over x. The absolute of x equals to x if x is positive, and it equals to negative x if x is negative. So here we have to use left-sided and right-sided limit. Limit as x approaches 0 from the right of the function. We'll also look at limit as x approaches 0 from the left of the same function, absolute of x over x. For the right-sided limit, since x is approaching from positive, so absolute of x equals to x. So limit as x approaches 0 from the right of x over x. X cancels with the x in the denominator, so this equals to 1. How about the left-sided limit? Since x is approaching from a negative value, so absolute of x is negative x. So limit as x approaches 0 from the left, absolute of x becomes negative x over x. The x cancels with the x in the denominator, but we still have a negative sign, so this equals to negative 1. So the left-sided limit of the function does not equal to the right-sided limit. Which means this limit does not exist. Let's look at a second example. Limit as x approaches 0 from the left of x times square root of 4 plus 9 over x squared. If we substitute 0, we'll get 0 times square root of 4 plus 9 over a really small number, which turns out to be infinity. And this is the same thing as 0 over 0. So we have to use some algebra to rewrite the function. Let's put the two terms in the square root in common denominator. Limit as x approaches 0 from the left of x times square root of 4x squared plus 9 over x squared. Let's pull the square root of x squared in the denominator outside the square root. So this equals to limit as x approaches 0 from the left of x over absolute of x times the remaining terms, square root of 4x squared plus 9. And since here we are computing the left-sided limit, which means x will be approaching from a negative value. So here, absolute of x is negative x. So this equals to limit as x approaches 0 from the left of x over negative x times square root of 4x squared plus 9. X in the numerator cancels with the x in the denominator. So this equals to limit as x approaches 0 from the left of negative square root of 4x squared plus 9. Then we use the chain rule. We substitute x by 0. We get negative square root of 9, which equals to negative 3. Let's look at one last example. Here's the limit. If we use the chain rule, we'll get infinity times infinity minus infinity. And infinity minus infinity is also indeterminate. Infinity minus infinity does not necessarily equal to 0. Now let's use the technique. Usually when we see square root and a minus sign, then we'll always try to complete the differences of squares. So let's do that. Limit as x approaches negative infinity of x times square root of x squared plus 1 minus square root of x squared minus 1. To complete the differences of squares, we are going to multiply by this term, but we are going to switch the minus sign to positive. So times square root of x squared plus 1 plus square root of x squared minus 1. And we have to divide by the same term. Square root of x squared plus 1 plus square root of x squared minus 1. So this becomes limit as x approaches negative infinity of x times the difference of square, that is x squared plus 1 minus x squared minus 1, divided by the same denominator, square root of x squared plus 1 plus square root of x squared minus 1. The x squared cancels with this minus x squared. So we are left with limit as x approaches negative infinity of 2x, and in the denominator, I'm going to factor out the x squared in the square root. So the denominator is square root of x squared times 1 plus 1 over x squared plus square root of x squared times 1 minus 1 over x squared. Then we can factor out the square root of x squared, which is absolute of x. So this equals limit as x approaches negative infinity of 2x over absolute of x times square root of 1 plus 1 over x squared plus square root of 1 minus 1 over x squared. Here the limit is limit as x approaches negative infinity. So this absolute of x, since it's approaching to a negative value, so it equals to negative x. Then we can cancel out the x in the numerator with the x in the denominator. So we are left with limit as x approaches negative infinity of negative 2 over square root of 1 plus 1 over x squared plus square root of 1 minus 1 over x squared. Then we use the chain rule. If we substitute the x in the 1 over x squared, they go to 0. So we are left with negative 2 over 2. So this limit equals to negative 1. And that is the end of the video. If you like my videos, please like and subscribe, and I'll see you in the next video.